Hi guys, thank you. Right, no further ado, let's just have a little look over what we're going to be talking about today. Now, we're not going to be focusing on any IPv attacks, i.e. no weaknesses with the protocol, but rather how we go about assessing an IPv6 host in our daily lives as pentesters or security consultants, or even, if you're admin in a system and so on. So the idea with this is just to give us a bit of, unfortunately you have to have a bit of theory about the addressing scheme, but then talk to, through some reality and some situations we may come across. So, first things first, addressing. We have to cover this because it's going to be appearing a lot throughout these slides. The link local address, so the FE80 addresses. Whenever you have a IPv6 enabled interface, you'll get one of these addresses. Okay, it's equivalent to your 169.254s in the IPv4 world. Not routable, but they're important, okay, in regards to what we're about to do. I'm not going to talk too much about the ULAs, but equivalent to your private IPv4 addressing. And the other important address type from our perspective, or my perspective with this talk, is the global. So the global addressing scheme on the 2000/3. So this is comparable to your public IPv4 addresses, okay? A couple of interesting addresses as well are these multicast values. So we've got FF02:1, which denotes anything that you send to this address will go to all nodes in the network, and the :2, all routers on the network, okay? Now this becomes quite useful in regards to host discovery, all right? So the first thing we've got here is a quick and easy, using ping6, how do we discover link local addresses or link local hosts on our local network? So these are, IPv6 enabled hosts on our local network. Well, easy enough, we can use ping6 and target this FF02:1, so all nodes will respond, and there are targets. Now, with a slight tweak of this command, we can essentially perform the same thing, but find all the global addresses on our local network. Now, a global address, it might not be assigned to every device, so we might not get as many respond, but they are very useful things to know. Now, the way we do this is exactly the same principle as the link local, except we use our global address, so we have to have a global address for our device. We use our global address as the source, and we'll get a list of global addresses on the local network. These sort of ping commands are very rudimentary. We're going across some of the limitations in a moment. The hacker's choice, the IPv6 tools, there are various tools in this tool set that allow us to do this, one of which is a Live 6. Now it's worth noting that in Kali rolling release, THC has been renamed to the ATK6 just to confuse, but they're the same tools, okay? And we use that in this second example. So this dirty one-liner, and I know this is dirty, I know it can be optimized, but it works, okay? This dirty one-liner will essentially get us all the IPv4 addresses, IPv6 link local, and global addresses from the hosts on our network. So we can see exactly what interfaces have, what address assigned. Now this is useful because we might have different services running on IPv4 or IPv6, which we'll look at, throughout the rest of this talk. So this is our first stage of host discovery. Taking this a step further, I said there were some limitations to that ping6 command. This is just using Scapy to create just a very raw packet. There's probably a lot, well, there is a lot missing here, but it does the job. We are targeting the FF02:1, so all nodes, and we get a response back from the nodes on our local network, as expected. Now, during testing, I did notice that Windows hosts don't respond to this. They literally just, they're there, but they don't respond. So, what we can do is basically craft an invalid packet and send this. Now, there's a lot wrong with this. It doesn't matter what, but in this case, we're supplying a new extended header option, and we're saying the length's 1, which is invalid. And in this case, in this scenario, only Windows hosts reply. Now, they reply with a, parameter problem in this case, but we know they exist, and we know their IPv6 address because they reply with this issue. So although it shouldn't work, it does work because Microsoft have looked at the RFCs and obviously implemented things slightly differently to everyone else. So there's one way to sort of get Windows hosts on the local network. It's also worth mentioning, I mentioned a Live 6 earlier, the same tool, that tool does this sort of manipulation, slightly different packets, but the same theory, okay? Now, when you do get access to a Windows host and you're using a Windows attacking box, there are a few gotchas in regards to SMB or UNC shares. If I've got a IPv6 target and I want to connect to an SMB share, I can't just do a // you know, like normal addressing scheme, because colons are not valid characters in a UNC path. So Microsoft, in their wisdom, has said, okay, we'll substitute the colons for hyphens, and then at the end we have to have this .IPv6 literal.net. So that's how we connect to a SMB share. It's worth noting, on a side note, I did find out this IPv6 .net is not actually owned by Microsoft these days. It's up for auction at the moment. So if you've got enough pennies, you can bid for this. It's got about 80 days left, I think, when I took this. It was only a day or two ago. It'd be interesting to see if any traffic goes out. That's all I'm saying. But back onto the topic. So that's local. Local's fairly easy in the world of IPv6. What about remote? So in this case, the address in red is a linked local address. We don't have routing capabilities, but we're trying to connect to a global address. This is a server sitting in DigitalOcean. You know, we're on our local LAN, we're trying to connect out, we don't get there. Now, if our ISP doesn't supply us with native IPv6 connections, which some still don't in the UK, or if you're tethering, you may not get a native IPv6 address. You can use something like a tunnel broker or a 6-to-4 address, which essentially, in regards to tunnel broker, is a proxy, for want of a better phrase. Your IPv6 enabled host talks to another IPv6 enabled host over an IPv4 network. Okay. It is worth noting, if you do use this, you are passing traffic through an unknown property, so just be aware of that. Now, in my case, I'm with BT. They do kindly present me with a global IPv6 address, so I didn't have to worry too much about that. So I can go straight into my recon. Now, a very cut down example of host recon. I've only got a few minutes to go through this. We're looking at the pings here. So we've got ping for IPv4 and ping for IPv6. You can see straight away, we're targeting the same host. We obviously get different responses in regards to the IP address, but we also see that IPv4 is giving no response where IPv6 responds. So there's obviously some difference in a configuration on the firewall, which we'll touch on throughout this. Similarly, in DNS, it's just another example of how you can, essentially find an IPv4, IPv6 address and so on. There are a lot of other things we're not touching on here. So now we know our target. In this case, it's going to be IPv6.rebootuser.com. Please don't try and hack it. It's not secure. It's for this demo. On the left-hand side, we have the IPv4, just a default Nmap scan, okay? So 1,000 ports. We have the IPv4 scan of it. On the right-hand side, we have an IPv6 scan of it. On IPv4, you can see we get 999 filtered ports and 1 open port. So it's behind the firewall. On the right-hand side, with IPv6, we get 998 closed ports, and we get 2 ports exposed. So it's not behind a firewall, and we get an extra service. So this is where, from a pen testing point of view, we always say we try and deduce the IPv4 and IPv6 address for this reason, because one may have been forgotten, and IPv6 is often forgotten. And again, we'll see some more as we go through. So this is the configuration, a white box approach now. This is the configuration of the host. It's running Nginx, and we get 2 different contents served depending on what you hit. So for IPv6, it's served from var www HTML IPv6, and you get this, you hit my IPv6 page, and it tells you your IPv6 address. IPv4, same principle, but it's served from /IPv4, okay? Now, if we go a little bit further, we're actually serving from the IPv6 only web route this WP directory, which is WordPress installation, whereas IPv4 we're not. So we're highlighting again, if you go to the IPv6 address, you'll get more content than if you see the IPv4 address. So stressing that point, you need to tackle both. So with that in mind, we found a target, okay? Well, how do we sort of see how do we run our normal tools? Some tools, in fact a lot of tools, seem to be IPv6 aware these days, which is great. In fact, when I was creating this presentation, I was struggling to find a commonly used tool that wasn't didn't have some sort of IPv6 awareness. But we've got an example here. We're using WP Scan. It's IPv6 aware, does exactly what it says on the tin. Okay, so we're scanning our WordPress installation. Nikto is not IPv6 aware, and we get some weird and wonderful errors. So what we can do is use SOCAT, and basically say to SOCAT, listen on my own box, listen on port 80, anything you hear on port 80, forward to this IPv6 address I'm telling you about. So then, Nikto, we just go, yep, just scan local box. Local box goes, okay, I'm going to scan myself. Oh, and SOCAT's telling me to go and hit IPv6 rebootuser.com, and it works as normal, okay? So a couple of really useful techniques to get around these limitations. Similarly, on Windows, I don't know how many of you guys use Windows for an attacking platform, but it's possible. It's just a bit more messy. Now, just to touch on a fact, I don't use Zap, so I'm not picking on Zap. The reason I've got Zap here is because it gives a nice error where it says failed to attack the URL IPv6 reference. So we can assume it's not an IPv6 compatible application. So we put an address in there and it fails. So what we can do is use NetSH and this port proxy interface. Now the port proxy interface is fantastic. You can use it for many things in the pen testing world. In this case, we're using it as a v4 to v6, so same principle as SOCAT. Listen on my local box, anything you hear on port 80, forward to this IPv6 address, okay? And then we point Zap to our local host and it runs as normal. That's the theory. Right, so this is going to be then the practical demo of all this sort of knowledge together, okay? So these are some IP tables rules. These are for the IPv6 rebootuser.com. This is what's in place. I'm going to talk you through these briefly. There's probably more than there should be due to WordPress. Essentially, anything that's not there is dropped, okay? So this is in or out, ingress or egress. The stuff in green is basically allowing our users to connect to our web app, okay? So that's allowed port 80 in. Next one down, which is a sort of orange, burgundy color, is our DNS. We need to allow our host to resolve. Now this lot in purple are WordPress specific IP addresses. I have to explain this just because when you use WordPress or try to add them in WordPress, you try to add a plugin, WordPress tries to connect out to the WordPress servers. As you might, if you ever used it, you might see it suggests these plugins, etc. These are the IPs I've found that you need to actually whitelist for that to happen. So that's all. That's the only reason they're in there. Anything that doesn't appear in here is dropped, in or out, and it's logged. Okay, so that's the important point. We log this. So, basic attack. We've got a WordPress installation. Somehow, unrelated to this attack, we don't care. The admin creds for WordPress have been leaked, whether it's for a phishing attack or whatever. I don't really mind. So we've got the creds for the WordPress installation, and we're going to use a basic module within Metasploit to basically upload a PHP file and get some reverse shell access. Again, doesn't matter what this is, it's unrelated. We're using it for the actual principle of the connection. So we set our configuration up. We put our credentials in. We put our reverse shell, or reverse interpreter shell to come back to our IPv4 address of our attacking box. And you can see on the victim, it is blocked. It's highlighted in red multiple times. We see this IP address with this port is blocked. Okay, that's what our IP rules are there for. Our IP table rules are there for. It's blocking it. So we succeed with authentication, but we don't get our shell back. But what about IPv6? Because people often forget this. And this is where we have IP6 tables. Now, it is a separate entity, so if you don't configure it, it's wide open by default. So basically, all we have to do from an attacking point of view is go, okay, let's we assume they've put some rules in here. Let's use our reverse shell. Let's connect it back to our IPv6 address. Bob's your uncle, straight through. We've got shell access and carry on the attack. And that's why we really need to pay more attention to IPv6 as well, okay? We find this on Pentest. If something's locked down, we might find, specifically with Linux boxes and IP tables, that it's only been IPv4 rules have only been applied, not IPv6. Just on a side note, there are tools like UFW for Ubuntu that actually configure both IPv4 and IPv6 in one. So, there are these sort of things out there. It's a one-hit wonder. And this is an example of an IP6 table rule that you can actually use to, essentially configure or give your system a bit more protection, shall we say. So that's a bit of a fix, depending on what you want to allow in and out. So just to finish things off, because I know there's a lot to pack into 15 minutes, there's a few resources I've used. One thing I will say, if you're interested in learning IPv6, now I know the basics to do my pen testing. I'm not a Cisco man, I don't know everything about the protocol, but the IPv6 Essentials book, there's an Amazon link there. I don't get any sort of credits or anything, but that is a fantastic read. It gives you a lot of info, the stuff you need to actually tackle this kind of thing. And that's it really. If you've got any questions, please let me know.